Hi there, my name is Nick. I typically don't make tutorial videos, but today I am covering Gamemaker and how it works with Steamworks for online multiplayer games. I haven't found a short, simple tutorial on the subject, so I spent the last couple weeks digging into the subject, reading documentation, and I wanted to present my findings in a simple way that hopefully anyone can understand and implement in their own game. I put together a little test prototype project, so if you want to download that, that's in the description. You can walk through the code as I walk through it in a little bit, and it just shows how I was able to put this together simply and fairly quickly. All right, let's talk about the structure that I'm going to be using for this implementation. I want to start by saying I am not a professional programmer, so hopefully this can be helpful to you, but you're going to want to build on it yourself. This should be a fairly simple, smooth implementation that hopefully anyone can get going on their own computer. So in this game, it's kind of like a Galaga-like game, but with multiplayer co-op. So each player controls their own ship. They control the logic for their own bullets that they fire. And then player one controls all the enemies. So player one controls player one, his bullets, and the enemies. And then player two controls his ship and his bullets. Now, each player will send this information over the network to the other player. So for instance, player one will send his character, his bullets, and the enemy's information over the network to the other player. And that other player, the receiving player, will create essentially mirrors of those objects that are on the other side. I call those drones in the project, but they're essentially blank objects that don't run any code on their own, but they receive data from the host every frame as to their X position, Y position, and their sprite index to animate them, as well as the image index as well. Now, this really works best for co-op games. It doesn't work as well for PvP action games or fighting games. With that, you want a more complex system like a rollback system or some sort of prediction system. Those are much more complex and really not necessary for co-op or a lot of other less speed-related games. So if you don't have PvP, this is going to be one of the simplest ways to implement this. All right, let's explain the tools we're going to be using to make this happen. The most important one that you're going to need is the buffer. If you don't know what a buffer is kind of like a DS list or an array. It's some sort of data structure, but with some slightly different functionality. It's not quite as easy to implement as something like a DS list, but we'll get into it a little bit more down below. There's a guy named Wizardy who does a great video on buffers. So if you'd like a more in-depth explanation of that, check the description below. Otherwise, I'll give you my explanation of how buffers work in this context. The biggest difference between a buffer and other data types is typically with another data type like a DS list or an array or even an object, you're going to be accessing individual variables whenever you want. So you can go look at the index of a DS list or an array, or you can go look up the X position of an object. With a buffer, it's not quite so easy. You typically are going to write everything in order, like one big list, start to finish, and then you're going to come back and read that off from start to finish in the same order you wrote it in. I like to imagine buffers kind of like trains. So when a train comes into the station, it's got an empty container for materials or a series of empty containers for materials. So if you're writing a buffer, you'd be writing a single piece of data into that first train cart. Then it would continue to go on and fill up a series of train carts going all the way back to the end. Once you have a full train, you can send it on its way. In this case, we'd be sending it through the network from one computer to another. And then when that train comes into the station on the other end, the receiving computer, you can begin unloading the train one piece of data at a time and sliding down and unloading. And then you can send all that data to its respective places. The other important thing about buffers is the size of each train car matters. When you write something to a DS list or an array, you typically just send the value into the array and don't think about it again. But it's a little different with buffers. Buffers, you have to pick the size of the train car. So for instance, if this 2-dot train car allows for two holes here. You have to fit the right size of data into the train car. So you could put a 1 or 2, in this case, bytes. You could put 1 or 2 bytes of data in here and that would work. But if you tried to fit something bigger than that into this buffer, you are going to run out of space when you are writing. So this is important. There's a whole list of different data sizes and types. You can go read that in the documentation. Again, I'll link that below as well. But essentially, you just have to pick the largest amount that number can be before you write it into the buffer. So if you're sending over an X position and say your coordinates go up to 500, then you can't use an 8-bit integer because an 8-bit integer can only go up to 255. So you have to prepare for how big your integers are going to be before you write them into the buffer. So that's buffers. The other thing that we have to quickly talk about is packets. A packet, to use another analogy, if the buffer is like a letter you're sending to somebody, the packet is the envelope that you put that letter in. So the packet just contains the buffer as it's sent through the network and then is received on the other end, which you pull out and begin reading through the buffer. Let's briefly go over what you'll need to make this work. Obviously, you'll need Gamemaker. You'll need the Steamworks extension in Gamemaker, which you can go download on the marketplace. You'll also need the Steamworks SDK, which you can download in your Steamworks dashboard. Now, you won't necessarily want to get the newest one. You'll want whichever one works with the Steamworks extension. So go check the documentation. Currently, it's number 161, but that'll change, month to month. So check the documentation and then download the appropriate SDK from Steam.
Father, please, can I have a Tic Tac?
Yeah. Once you've imported the Steamworks extension into Gamemaker, you'll want to set the Steam app ID to the game that you're working on currently. 480 works for testing some things. It does not work here in this game, so you'll want to set it to an actual Steam app ID that you have control over. All right, now we're inside Gamemaker, and I'm going to give you a quick tour of the code. Firstly, you want to open up the Steamworks extension, and here you can see this is where you're going to be changing your app ID. You'll also want to find a place where you saved your SDK so it can access that to build the game and run within Steam. Now we've got two rooms here. We've got the lobby and the actual game. So this is where the game's going to take place. And this is where all the handling of the lobby matchmaking works. Now, the lobby and matchmaking code here is very primitive. I would not suggest using this kind of setup on your own game without expanding on it further. I've linked a video in the description that actually goes deeper on how to do lobby and matchmaking well. I did not care to do the UI for that. So essentially the host button sets up a lobby for the host of the game, and the join button immediately joins whatever the first lobby is on that Steam app ID. And that's why I recommended you don't use 480, because if anybody else is testing, it's not going to connect properly. So if you have two computers, you'll have one click host, one hit join, and then you'll be in the game together. And the way that room is set up is you have a host button and a join button. If you hit the host button, it creates a lobby here and it sets it to public. You can do friends only or private, but in this case, I'm just doing public. It creates a lobby. If you click the join button, it requests a list of all the current Steam lobbies for that game. And now this next part is actually doing all the legwork. So there's an event here called a async Steam event, which essentially in this previous event that creates a lobby, or the other one that requests a list of the lobbies, that sends out a request to Steam. And then eventually that information will come back through the Steam async event. So right here, it's listening for that event to come back. And then we're going to go through a couple different options. So an event is going to come in from Steam, and then you're going to look it up through this async load table. And we're going to look for something called lobby created, a lobby list, or lobby joined. If you would click the host button, then the event that's going to come back is lobby created. At that time, it's going to join that lobby, which is going to send another request to Steam, which is going to send another information packet back to us, which says lobby joined. So if now you have joined your own lobby, if you're the owner, it's going to set the data type creator to your name, which you can use for other purposes. I don't really use it for anything yet. And then it sets the game mode to 1, which is just a global variable I have set. We'll talk about that in a minute. And it goes to the actual game room. So that's what happens if you hit the host button. If you hit the join button, it's going to return an event called lobby list. And it's going to give you the current list count of all the lobbies. And then it automatically joins the first lobby. Again, this is not recommended. If you actually want to implement this, I would fix this section here and make some UI surrounding how to select lists. For this purpose, I just wanted to get it working so we can get to the buffer sending in a little bit. So you get the lobby list back, it gets the lobby list count, it joins the lobby, and then down here, it checks to see if you're the owner of the lobby again. In this case, we are not the owner of the lobby, so it sets the game mode to 2, which is the client, and the global connected player is set to the other person. And it goes to the game room. So that's the quick overview of joining the lobby or hosting the lobby. So that's everything there is about joining and hosting lobbies. I think there's one other event over in the game, async event, that comes in here. If the player who is hosting gets a notification that someone has joined their lobby, it sets the connected player to that person who just joined. So now you have 2 people in one lobby. One is the host, one is the client or the other member, and they both have a global.connectedPlayer variable set to the other one's ID. This is important because you're going to need to send those packets to those IDs. Now, looking again at the structure of the game, if you remember, I had said that the player who hosts the game is going to be the one controlling the enemies. So on my enemy spawner here, it checks to see if you are not the client, if you're either playing solo or you are the host. Then it's going to begin spawning enemies, which I do through this alarm. So every 60 seconds, or this actually sets it a little bit more randomly than that, it spawns an enemy. If you are not the host, it will never kick off this sequence, and you will not be spawning your own enemies. And here we have the drone object, which literally doesn't have any code in it. Again, we are going to apply X, Y, and image values to this object every frame that we receive from the other player. All right, now let's walk through the game object. This is really the brains of the whole thing. So you probably are familiar with the step event in Gamemaker. The way we're working with this is that the game logic all happens in the step event, and then the end step event is used to send the network data to the across to either player, and then at the begin step event, you receive that network data for the next step. So you receive data, you process it, do things, and then you send out the result to the other player. So we are going to start, well, actually, we'll start with the create event here. So global game mode starts at 0. So 0 is solo, 1 is the host, and 2 is the client. Then we talked about the connected player. You're going to want to set that to undefined at the beginning so that you can later change that and not cause problems. We'll get to the update sequence in a little bit. And then these 4 DS lists, or one of them is actually a DS map, but these 4 lists are kind of the main hub of information that comes and goes. So we have an entity list, a destroy list, a hit list, and the drone IDs. And I'll explain how all of these work in a little bit, but there's comments on this as well. And then we have 3 packet types that I've just created as an enum here. You can have a hit packet, a destroy packet, or an update packet. So the destroy packet is going to be sent from the host to the client whenever the person hosting an object. So you have hit, destroy, and update. So those are the 3 kinds of information that we're passing between the players. You may have more depending on the kinds of information that your game has in it. But for this very simple explanation, we have hits, we have destroys, and we have the step update that runs every single frame. Let's jump into the end step event. So again, the end step event is where we're going to be sending all of our network data. And so we're going to be writing a buffer, putting a bunch of information in it, that train like we talked about, and then we're going to ship that train off to the other player. We'll start with the send update event because this is the one that's going to be running every single frame. It's going to be sending over probably the most data. So let's start there. Now it's important to note that both players are sending and receiving data in this setup. You don't have one person being the host of all the information because both players have some things that they send over. So, right, both players send their own player information, their own bullets, and it's just the host who also does the enemy information as well. So, in this case, we're going to be writing a buffer. The first thing we want to do with a buffer is, even before we write the buffer, is we want to figure out how big this buffer is going to be. How long is this train going to be before we load it up with stuff? In this case, we're going to kind of assess based on how many entities we have, right? If we know we have, ourselves, and then 5 enemies and 2 bullets, right? It's going to automatically, we have a list for that automatically adds every instance of those things to this list, so we know how big it's going to be when we send it over. And then we multiply that by 12. 12 is not a random number. 12 is if you add up all these things that we're going to write into the buffer, right, we're going to put a 32-bit integer, and then a couple 16-bit floats, another 16-bit integer, and one more 16-bit float. So we're putting in 12 bytes of data, and that's all right here. So per entity, for every entity that we have, we're going to be writing in 12 bytes of data into our buffer. So we know we need 12 bytes of data for that. And then we're going to need an additional 5 bytes of data for these two things here, which is the packet enum and the update sequence, which I'll explain how that works in a little bit. But in short, you're going to want to size your buffer based on everything that you're going to be putting into it. Then you create the buffer. So in this case, we're going to assign it the name buff. You create a buffer based on our buffer size. In this case, we're doing buffer fixed because we know exactly how big this buffer is going to be. And then you align it to 1 bit. I don't understand how alignment works, but based on what I understand about network code is you only ever need to align it to 1 bit. So just put 1 there and don't think about it again. Now, the first thing that you're going to write into your buffer is something that tells the buffer where to go. Think of this as the engine of the train. So when you send this out, you're going to want to send over some information that says where this stuff goes. And I'll show you how that works on the other side in a bit. But the first byte of data needs to tell the receiver where it's going. All right, the next thing you're going to write into your buffer is the update sequence. Now, before I talk about that, let me talk a little bit about packet types. So if you look here, we have Steam Net packet type reliable and Steam Net packet type unreliable. So there are 2 kinds of ways to send data. You can either send it very fast, but unreliably, which just spits the data out and hopes it gets there. Or you can send it out slower, but it's more reliable. So for your update sequence, I would recommend doing an unreliable packet type, because what that means is it'll get there quickly, and it just kind of spits the data over there. If you drop a frame, it doesn't matter because the next frame's coming and it'll correct. Not a huge deal. For things like spawning, hits, destruction, anything that needs to be registered once, that you're going to want to send over as reliable. It might not get there as fast, but you want to make sure it gets there. So with unreliable packets, not only can they not get there, but sometimes they can arrive out of order. So say you get 1, then 3, and then 2. If an object is moving in one direction, it might jump around a little bit along its x-axis. We don't want that, so we're going to send over a sequence so that the receiver can look at it and say, okay, is this a new one or is this an old one? If it's an old one, it discards it. And if it's a new one, then it processes the information. All right, now that we've sent over the packet information and the sequence information, we want to send over the object information. So we do a for loop here that goes through the list of entities that this player is controlling, and it sends over the ID, the local ID, so that you can apply that to the other end, the X position, the Y position, the sprite index, and the image index. Now, this is super simple. You can add or subtract or change anything here. You don't need to send over this set of data, but you can add, for instance, if you wanted to add a draw color, say your character is being drawn in different colors, then you might want to send that over so that it can draw it a different color for the other player. Whatever information you want to send over, you write it to this buffer. And obviously, if you're going to be adding additional integers that you're writing to it, you'll need to adjust the packet size information up here. Or you can just change your buffer fixed to a style called buffer grow, which will allow it to grow, and then you don't really have to think about it that much. But it is a little bit slower from what I understand. Now, once you have all of the data written into your buffer, you have ID, X, Y, sprite index, image index. You have all of that for every single ID written all in order. So you have your train cars all in a row: ID, X, Y, sprite index, image index. ID, X, Y, sprite index, image index. You have a bunch of those all in a row. You're going to put that into a packet, and it's going to check to see if there's somebody connected to the game here, and then it's going to send that over through Steam to the connected player. It's going to send the buffer over. It's going to, how long the buffer is, you use buffer tell here, which you can read about in the documentation. And again, we're going to be using unreliable in the information. You then delete the buff because they do not garbage collect on their own, and then you update the sequence at the end of this frame. So that is the update. That is the full update. Now let's go back to the begin step and see how are we going to read this information when it comes through. So the first thing that we do is at the begin step of this event, we have a while loop, which is Steam net packet received. So as long as there's a packet coming in, it's going to read that packet and do stuff with it. So if we have a packet that comes in, the first thing we're going to do is find out how big the packet is. Then we're going to create a new buffer. So it doesn't really work with the train analogy, but you have to take all that information from the packet and copy it into a buffer. So you've received the data, you're putting into this new buffer called received buffer or rec buffer here. Then you go to the very beginning of that buffer. So you've written this new buffer with all the Steam data, and you're going to go to the very beginning of that buffer. And what's going to be at the beginning of the buffer? The first thing that's going to be at the beginning of our buffer is our packet enum that we sent before. So we're going to read that 8-bit integer off because we're always sent over the 8-bit integer first, which is the packet enum. And it's going to check and find out what kind of data we are dealing with. So in this case, we have packet sort, and then we do a switch case statement for the packet sort. So again, we're using the update enum that we just sent over from before. Now we skip down to the update section here. And the first thing that it's going to do, it's going to read the buffer that we wrote, which was the sequence buffer. And then it's going to check and see if this is a new or current frame, or if it's an old piece of data. If it's an old piece of data, it skips all of this and we don't do an update with it because it's old data. We don't want it. But if it is new, it updates the sequence so that we're on the current frame now. Then it goes through a for loop. So if you see here, we've got a for loop, and it's pulling off all that same data that matches the end step of before, right? We've got ID, X, Y, sprite, image. Right? So we're going through that same kind of data in the same order. Again, if you see here, we have to tell it what kind of data to read, right? We're reading a 32-bit integer. We're reading a 16-bit float. So you have to make sure that everything you're sending over matches the way that it's being read off on the other end. You have to control both sides. So we've received this train. We've unloaded the first 5 cars of data, the first one being the received ID. So if you remember, we sent over an ID from the host to the client, player 1 to player 2, or player 2 to player 1, either one. Whoever's sending the data sends over the ID of the objects that they are controlling. So if this case, say we're using the player, right? So the first one we unload, say it's the player object from the other side. We unload its ID. We first check to see, have we already created something with this information before? Because if we have not created something with this information, we're going to create a new object. If that object does already exist, then all we're going to do is we're going to find that object and we're going to give it a new X position, the new Y position, new sprite index, and a new image index. That's all we're going to do. We're going to take that information, we're going to immediately apply it. That's super simple. Now, if we haven't created something, and this part you could do in different ways. You could send over individual spawn code, but the way I have it here is if a update packet comes across and we don't have something spawned, then we just spawn it here in the code. We spawn a drone for the host's object that it sent over. So we check the DS map, which is the drone IDs. So the drone IDs, so we have all these blank objects that we keep in a list or in a map that is mapped with the local IDs to the IDs that the other player has hosted. This can get kind of tricky. Try not to get too confused by this part, but essentially you are creating a list of items that are indexed by the network ID of the other player's objects. Hopefully that makes sense. It barely makes sense to me. But then you go ahead and create a new instance of a drone. You set that drone's network ID to the other person's ID. So the host has an instance ID on its end, and you give it an ID called network ID or whatever you want to call it. That way you know that this object over here is reference of a real object that exists over in the host's computer. And then you add it to that same DS map, which is indexed by its received ID. Again, hopefully that makes sense. It's a little tricky. And then you go ahead and, again, either way, you still give it the same X, Y, sprite index, and image index. You just have to create it first if you're not, if it's not created yet. And that's it for the update event. It's kind of tricky, but once you understand what you're doing, you're just sending trains and receiving trains. And if you receive a train with information you haven't gotten yet, you create an object to apply that information to, and then you just continue to receive those trains with information, pull it off, and apply it to the objects. Okay, so we've covered update. Let's get into destroy. So if you want to destroy something, you need to tell the other player that you have destroyed it. So in this case, destroy is for the person hosting the thing. So if you see here, it says destroy local enemies, sends IDs to other player to delete the drones. So if I am the person hosting the enemies, I shoot an enemy, I destroy it, I'm going to want to send the ID of that thing that I've destroyed to the other player. So similar thing as before, we're going to create a, we're going to use the destroy list to create a buffer, and then we're going to write in the packet enum destroy. We're going to update the or we're going to use the update sequence for reasons I'll explain in a little bit. Then for everything on your destroy list, you're going to want to write it into the buffer and then destroy it. That's the basic idea of what we're doing here. We're writing that ID into the buffer to send over to the other player, and then you destroy the instance. That's it. On the receiving end, we'll go back to the beginning step. We're going to receive the packet again, same way. It goes through the same loop that we did with the previous one, except instead of going down to update, we go over to destroy. Then we're going to read the buffer, and now we're going to check the sequence. And again, this is also important. You want to check the sequence even if it's unreliable, because what happens is it's going to send over a sequence, and say you receive the sequence, you do the destroy event, and then you get an old piece of data that you didn't mean to get. That's going to create a new drone object with that information. So you don't want that happening. So what you want to do is you want to update the sequence and then run this code regardless of whether it's new or not. You might have an update that's newer than this, right? You might have something that was sent over already. That doesn't matter. You want to make sure that you still destroy it no matter where it's at in the process. So a destroy packet may come in late, but you still want to destroy it, and you still want to update the sequence if it's newer so that you don't end up with old data ruining your destroy event. Now, same thing as before, except instead of X, Y, sprite, and image, all we're checking for is the ID, because we're going to use that ID to look up the drone and destroy it, right? Because the person sent over the packet of drones to destroy. Now we're receiving the packet of drones to destroy. So we're going to look through the list of drone IDs that we have. So we're going to say if the DS map exists drone IDs, and we're going to look for the entry that is mapped by the received ID, which will give us the network ID that we can then check against and then destroy. I know, a little convoluted. There might be easier ways or simpler ways. I did find one simpler way, but it was a little more computationally heavy, so I went with this way. And then you remove it from the DS map drone ID, so it doesn't get updated anymore. That drone is deleted. So when the host destroys a drone, it sends that information over to the client, and then that drone is destroyed on the client side. It updates the sequence so that there's no new information about that drone that'll ever come in after that. That is the destroy event. Finally, we have the hit packet. So we talked about what happens if the host destroys an enemy. What happens if a client shoots an enemy? If the client shoots an enemy, we don't have direct control over the enemies on that side. So we need to hit the drone, tell the host we've hit that drone, so the drone can destroy it, and tell the client again to destroy the drone. So it kind of goes back and forth a little bit. That could be seen as convoluted. There are reasons why you might want to do that or might not want to do that. You could have it that the player just destroys the drone and that tells the host to destroy it, but that can get a little tricky and cause different problems. So I decided to have the host be the authoritative control over the enemies, and so the client just has to send a hit, which then sends a destroy back. So again, we're doing the same thing as before. We're going to create a buffer. It's going to send over the packet enum hit so that the other side knows it's a hit. We're going to send the update sequence, and we're going to send a list of everything that was hit this frame, and then it clears the hit list so it can be used next time. Then we send over the packet again. Again, this is a reliable packet because we want this to get there every single time, regardless of the order it's received or anything like that. We have to make sure that information gets to the player and then comes back with a destroy. And then we have the buffer delete, which deletes the buffer. And finally, going back to the received information, we receive a packet and we look for a hit. If it's hit, again, it's going to update the sequence, but run the code regardless of if it's a new sequence or not. And then down here, we're going to go through every single object that comes through. And if that instance exists, we're going to add it to the destroy list, because again, if we add it to the destroy list, it's going to get sent back to the other player as a destroy, and then we're going to destroy that object on this side. And that's most of the code that goes into this game. All right, and that's about it. That's about everything you need to run an online multiplayer co-op game through Steamworks with Gamemaker. You might want to download the repo. There are code comments on everything I did. You can see exactly what happens when a bullet hits an enemy versus a bullet hitting a drone, how those various lists work, and when things get added to them and deleted from them and things like that. So go ahead and download the game. Check it out for yourself. Try to implement it in your own game. I would love to hear if you do implement it in your own game. Feel free to use anything you hear in this video for free. And thanks for watching, and hopefully this helps you. If you have any questions or issues or anything like that, leave them in the comments below. I'm sure my code has some bugs in it, so let me know that as well. And I'll pin any comments with any updates or anything like that below. But yeah, thanks for watching.
Hey, Father, can I please have a tic tac?